All right, so today we are talking about logic, which basically means we're going to be looking at a bunch of statements and determining whether they are true or false, right? So anytime we see this phrase truth value, literally just means, is this true or false? So, example, a rectangle is a quadrilateral. That is true, so the truth value is marked as a T. A couple of statements that we need to know, or terms we need to know as well. Whenever we see this word negation, it just means not. Right? So you're going to take the statement you had and add a not to it. Or you're going to say sort of the opposite of whatever you originally said. This is going to be marked with this little squiggly, right? So little tilde. You can almost think of it like a negative sign. So when you see something written like that, what they are saying is not statement P. So if statement P was this guy, not P is the same sentence. They just added the word not to it, which means that the statement that was originally true is now false. Because again, it's just the opposite. The next thing that we need to be aware of are compound statements. So we use these a lot in our real life. A compound statement is just whenever you take two statements and put them together. So for example, if you say two things combined with the word and in the middle, that's a compound statement. Specifically, it is a conjunction. So if I give you two statements, say we have these two, right? A rectangle is a quadrilateral. A rectangle is convex. So to combine these together, we will just recopy the two statements and place and in the middle. So P and Q means a rectangle is a quadrilateral and a rectangle is convex. So if you make a conjunction and you want to write it out using symbols, instead of writing the word and, you can just put this little upside down V, or another way to think of it is that it's an A with the line in the middle removed. Basically, your and statement or your conjunction will be true as long as the whole thing is true. We're looking at an example. This tells me that I need to write P and R. So here's statement P. Here's statement R. So the figure is a triangle. And the figure has three congruent angles, three acute angles. All right, so if we look at this, is the figure a triangle? Yes, so the first part is true. Do we have three acute angles? No, because one of the angles was marked as a right angle. So a conjunction can only be true if the whole thing is true. Therefore, this statement is false. Let's try one with an and. A not. So let's see, we've got the negation here, which means we need to add a not. We want statement Q and not R. So statement Q. The figure has two congruent sides. And we need to put the not R. So instead of saying that the figure has three acute angles, we will say that the figure does not have three acute angles. Okay, so there's our statement. Now we need to figure out whether this is true or false. So, does the figure have two congruent sides? Yes, because they marked two of our sides with these little tick marks. That tells us they are supposed to be congruent. The figure does not have three acute angles. That is true because we've got two acute angles and one right angle. So the whole sentence is true. So we're going to say that the statement is true. All right, 1A and 1B, you can try on your own. So we got the next thing. Okay, so another type of compound statement is a disjunction. This means they are connected with the word or. So again, example, P or Q means write statement P, write statement Q, and put an or. The symbol for this looks like a B. So and looks like an A with the middle cut out, or is just the A flipped over, so it's a V. These are going to work the same way. The biggest difference, though, is that in order for an or statement to be true, you only need part of the sentence to work. So, I'm just going to do this first one. We need Q or R. So January has only 30 days, or January is the first day of the new year. Well, we know the first part's wrong because January has 31 days. But the second part is true. It is the first day of the year. So since we connected this using an or, as long as it's at least partly true, we're going to say that the whole sentence counts as true. Because remember, everything has to count as either true or false. In logic, there is no in between. All right, I will let you try the rest of these. Again, connect the sentences, use the word or, and then determine true or false. This is basically just a recap of what we just said. The next thing is truth tables. So to make a truth table, basically we're just going to take our two statements, determine whether they're true and false, and look at how all these different combinations can determine whether the and statements or statements are true and false. I know it looks confusing, but with a little practice, we can hopefully sort of get the hang of these. So when we are constructing our truth tables, they're going to give us the thing that we're trying to find the truth values of. So for this example, we're looking at the statement not P or Q. So if they don't give us a table to fill in, we'll have to make one. So we're going to want columns for each of the letters. I notice I have a not P, so I'm going to want a negation for P. And then I'm going to need the compound statement as the final column. All right. So what we're going to do now, notice in the examples, the first two columns are just every combination of true and false that we can think of. So if P is true, Q could also be true. I could have it where P is true, Q is false. I could have a false and a true, or I could have two falses. Again, we don't know what these statements are, so we're not sure which one's true and which one's false, so we just need to make something for every option. We said that the negation is literally the opposite. So I'm just going to take column P. All the F's become T's, and all the T's become F's. And finally, we said an OR statement is true as long as at least one part of the sentence was true. So when I'm looking at these, I want to know whether not P or Q is true. So as long as I see at least one T, I can say it's T. So the first one's true. The second one is false. The third one is true. And the last one is true. And that is all we have to do. All right, and the last example that we're going to look at today is reading a Venn diagram. So we can use Venn diagrams to make the and or statements. The stuff in the middle, where the two circles overlap, that's where everything is and. If they say or, you're going to include everything that is in both circles. So how many people can attend the May or June meeting? Well, I have 5 people in the May circle. I have 6 people in the middle, and then 14 over here. So add them up, 25 people. How many people can do May and June? Okay, that's only in the middle, so there's 6. And then finally, what can we say about the 14 people that are only in the June circle? Well, that means they can only attend the June meeting. All right, that's all for today, and I will see you next time.